Alright, got the floppy drive removed, and that frees up this little circuit board here. And as I found out in editing the previous video, that this chip right here is a hard drive controller, so apparently this whole board is just for controlling the hard drive, which was plugged in right here. Back to the floppy drive now. I took the covers off already, and it's really nothing special, nothing I haven't seen in any other floppy drive of this vintage. Speaking of vintage, I'm seeing date codes here, 8903, and here's another one, 8924. And where did I? Oh yeah, on the motor itself, the stepper motor that drives the heads back and forth, 8902. So it looks like a 1989 computer, not 1988. It's got two board construction here for all the digital communications and data handling stuff right here, and then this is just motor driver on this board right here with little Hall effect sensor there to sense when this tiny little magnet goes by it, and it'll regulate the speed. And it's got two read-write heads over here with two connections going to the circuit board, and it really seems no different than any standard 1.44 kilobyte or 1.44 megabyte floppy drive. And I'm surprised that it's formatted for 360 kilobyte, because the hardware seems to be identical to any other regular floppy drive. As for connections, it had the main data connection here, power supply connection, only two wires going to it, ground, and it looks like 5 volt on the red wire. And another thing that's unusual, I really haven't seen before on a floppy disk drive, is this little tiny switch right here. Let's see how many positions that is. It's 1, 2, 3, 4. 4-position slide switch. Now for the power supply board. After removing one screw from right here, we can unplug it. It's just held in place by these two strip connectors down there. And here it is. Oh, and also this piece comes off. So this is just the power switch and the input connector, and looks like a common mode choke right there. And another tiny little choke, and then that just connects onto the other circuit board. I'm not sure why they did that. Got a fuse, and basically it's just a regular switching power supply. So apparently it doesn't need exactly 12 volt input. It could be anywhere from 12 to 15 volts unregulated, and then this power supply would just take care of that and regulate it and convert it into whatever voltage it needs to run the laptop. And it does that mostly, apparently, with this part, this STK7702, and I looked it up already. It's this Sanyo voltage regulator for office automation equipment. And you can see all the different voltages it puts out: 12.0, 8.2, 5.05, negative 12.4, 5.0, and negative 15.3. So that's just mounted on a heat sink. Big aluminum plate here. Same. This is the output diode. Output from the transformer, going to the diode, going to these two capacitors here. And also, this transformer has 4 turns of wire wrapped around it and short-circuited to itself, and that's just to cut down on any magnetically coupled noise that might be coming out of the transformer. It just cuts down on keeping the noise to a minimum. There's also this little connector here. It looks like 80 mil spacing on these terminals, and that wasn't hooked up to anything inside the laptop, so I'm not sure what that would be for. Another mystery connector is this one right here on the motherboard. This 40-pin 0.1-inch spacing connector on the front of the computer. There's no access panel or anything right here in the plastic case. So I guess this would be for programming or diagnostics or something. And then there's another couple of connectors back here. And again, these were not hooked up to anything. Anyway, let's have a look at the bottom of the motherboard. I have not seen this yet. Oh man, look at all this awesome stuff. Looks like we got 2 BIOS chips. And that's all the RAM right here. Let's see, which one of these is that? The microprocessor, the ADC88. Okay, so that's awesome that it has a 8088 on this motherboard here. Truly vintage technology. And then there's this mystery chip right here. I looked it up. I couldn't find any information on it other than a bunch of places that seem to be selling it. L1A0612, and it's a Zenith part. And then there's this slot over here. This is the empty slot we saw in the beginning on the bottom of the computer. And that's for the 8087, the floating point coprocessor to be associated with the 8088 or 8086 if there was an 86 in there. As for the RAM, it's got 16 of these Mitsubishi RAM chips and then another 4 of these NEC chips. These are the part numbers here, easier to read. M54256AP, and in this case we're looking at -12. There's the package, the PLCC. Anyway, these are 262,144 bit, which works out to 32 kilobyte each. And you multiply that by the 20 chips on here, and you get 640 kilobyte of RAM. The other NEC chip, that's this D41464L-12. Couldn't find any information on that. On second thought, looks like I did find some information. I just tapped on one of those links there on the Google search and I found this one here. Good quality NEC datasheet, and this figure right here, that works out to 32 kilobytes as well. So it's functionally identical. These 4 NEC chips are the same as all the other Mitsubishis. It's just a mystery as to why there's 2 different manufacturer chips on here. And then there's these other 2 connectors that we saw on the other side of the board. Looking at it now, they probably are for RAM expansion packs that you would put on the inside here on the motherboard. Another interesting thing here is the Cmos clock backup capacitor here, a whopping 1.0 farads and 5.5 volt. I'm really surprised to see a super cap in here. I was expecting a NiCad battery or something like that in here, but it's good that they have a super cap, because there's nothing worse than opening up an old vintage computer and you hope everything's all nice and pretty in there, and then you find that the NiCad battery had just leaked a bunch of crap all over and ate away all the copper traces. I hate when that happens. I'm starting to put this thing back together, and you can see how the one connector on the corner of the motherboard goes to a little open space right here below the keyboard. So that must be for some kind of extra peripheral to plug in there. And also, I realized that this connector up here, little mystery connector on the power supply board, that goes to the monitor. Duh. I took it out of there and I didn't even realize it, but that's the monitor connection right there. Speaking of which, we're going to take this apart next. So to open the monitor, there's these 2 small screws on the bottom of it. Oh, and this little hinge pops open like that, so that shows the wires, the ribbon cable going through there. I have a feeling that as I do this, I'm going to completely shatter every single little tab that holds this thing together. Okay. Wow. Look at all those chips. And sure enough, here's all the little pieces of plastic that I managed to snap off. And oh man, look at that. This thing came completely off its hinges too. Anyway, there's this sheet of laminated copper here, laminated copper foil, and these little latch mechanisms are very interesting. You can see how this thing is, there's no spring action here at all, so when I have it down like that, if the monitor is down like this, or if the whole computer is upside down, and I try to pull on the piece of plastic to open it up, it doesn't budge. But if this is flipped over like that, as it would be if the computer was right side up, then gravity pulls this thing down. Just like that. And then that gets released and I can open up the computer. Oh man, this is most unexpected. I just took a quick look at this, and there's these wires, the red and black wire, hooked up to this little circuit board here, and they snake over here, go to two little tabs on the side of the main board, and that looks mysteriously like how you would see with any kind of little LCD module with a backlight that you would buy for any kind of embedded application, which in that case it would be LEDs, but you know, there was no white LEDs back in 1989 when this thing was made. So I can just see like there's this thin film apparently that those two tabs go to. Where the heck is it? There we go. Yeah, you can see the wire snaking on this side of it and going to this film-like material, and that of course would be an electroluminescent material. This big, long, wide electroluminescent plate, and that would explain why it's so dim even at maximum brightness, because as these things age, they greatly lose their brightness. So what's going on with all these LCD driver chips here? Well, first of all, their part number is MSM5279 from this Oki, Japanese Oki company, and they are 80 dot segment driver. So they have 80 individual bit outputs on this 100 pin quad flat pack. And secondly, I found the service manual for the damn thing. So I'll put a link down below for this service manual, and I'll get more into it later. But right now for the LCD, it's a 25 row 80 column LCD with resolution of 640 by 200 pixels. And if you do the math, you have 80 pixels. These control the vertical columns. Each pixel row or each pixel column is controlled by these things, and 8 of these chips times 80 columns per chip, and you get 640 columns going all the way across. But then there's another set of 8 chips right here, and so I think what they're doing is they have the bottom half of the LCD is controlled by these 8 chips, and the top half of the LCD is controlled by these 8 chips. As for the horizontal pixel rows, there's only these 2 other chips, and you can, follow the traces, and you see that pretty much all the traces from this IC come up to here to the top half, and then that one goes down here to the bottom half. But again, according to the specs, we're looking at 200 pixel rows, and with these 2 chips we only have the capacity for 160. So I think maybe on the other side of the board there's going to be some extra traces where these things are both acting together on the top half when all these 8 chips are active, and then these act together to control the bottom half when all of these 8 chips are active. Okay, so this is the circuit board with the sliders on it for the brightness and the contrast, and it's just a linear pot here, 100 kilobyte or 100 kilo ohm, and this one's a 50 kilo ohm. Little capacitor on there, and that's it. There's 8 conductors from this ribbon cable going up to this board, and the electroluminescent backlight is controlled directly with this one being ground, and then the other trace goes right here directly to one of these, directly to this one right here. And you can see how they put a space here between this wire and the next wire over. There's a one terminal space, and I think that's just because electroluminescent needs high voltage in order to work, and so they wanted to make sure that the high voltage would not be arcing onto anything else and causing some big problems there. And so I guess this brightness pot, that's going to feed back, that's just connected directly down into the power supply located right down here, and then that'll tell the power supply how much voltage to apply to the electroluminescent and control the brightness. I just took 6 screws out of that monitor. Let's see what happens when we flip it over. Look at that. That is the biggest LCD dot matrix display that I've ever seen. And I don't mean modern day LCD monitors or TVs. I mean, this is very similar construction to any kind of regular LCD dot matrix display that you would have in some kind of project that you might be working on, something like a 2 by 20 character. But this one is a 25 by 80 character. And on the top of the board here, we can see a few of these traces coming up from the bottom and then going to the LCD connections, but really can't see much. And I'm not going to untwist all these little tabs here on the middle frame and take the LCD off, because I don't want to damage any of the connections to it, which is it's a couple of zebra stripes here, or zebra stripe rubber connector going across the top and the bottom of the LCD. And also on the left side there's I can't really show it very well on camera, but trust me that there is, yeah, there we go. You can see that little curve inside there, and that's the flat flex cable or flat flex strip going from the circuit board and looping up to the LCD. And if I break that, there's no way I'd be able to get it back together. There's some other classic chips here on the other side of the board. We've got a 4017 decade counter, and then here's a 4013 flip-flop, and we got a 324 op amp going right here, quad op amp. I'm not sure what the op amp is doing, but you can see that the outputs on the 4 corner pins, they're hooked up directly to the inverting inputs. So apparently this is acting as nothing more than a bunch of voltage followers. And as for these things down here, my guess, this is entirely a guess, is that the flip-flop selects either the, what is this? This would be the bottom row or the top row of LCD drivers, and then the 4017 that switches from one chip to another, depending on whether it's going on the bottom or on the top from one to another, and then re-triggering after the 8th one, going back to the first. Finally, there's this other little tiny board right here. That's just the 3 LEDs for the low power and the right and left drives. Nothing special there. I had a sneaking suspicion that this quad op amp could be controlling the LCD contrast, and apparently that seems to be true. I looked at the data sheet and we see a circuit very similar to what's on here. You can see that there's a bunch of resistors R, and then another one that's 7 times R. And on here, R2, R4, and R5 are all 1 kiloohm, and then R3 is a 6.8 kiloohm, so almost 7 times the other 3 resistors. Plus we got a capacitor here, another little variable resistor right there, and so that might be this one here. But basically this is just a 4-level voltage controller, so that each individual pixel could have the potential to be to have 4 different intensity levels. And it says at the top of the data sheet here, 80-bit 4-level driver. So as far as the hardware is concerned, the individual LCD pixels could have different intensities and not just be single on-off monochrome. But I really haven't noticed if it was actually variable intensity. I'll have to check for that when I get this thing back together and turn on the computer again.